In this video, I'm going to talk about quadrat sampling, which is one of two sampling methods that we'll learn about this outcome. And this is in our unit on how to characterize ecological populations. You should have some guided notes to go along with this, so go ahead and get those if you need them. So population density is actually often presented as a fraction. It's the number of, in this case, humans in a given area. Okay, so it could also be for dandelions, right? So maybe 200,000 per whatever the area is in Perry Farm, for example. Okay, population density is a helpful descriptor of a population within a given ecosystem. It shows how many are packed in together. And we often use population density to assess the health of an ecosystem or the status of a population. Sometimes overcrowding is a bad thing, but it also means that if we have a lot of individuals in a given area, that perhaps the population is doing quite well. So sampling, if you haven't gathered already, sampling is taking samples from different parts of the ecosystem in order to estimate the total population within a larger area. Obviously, we can't count all of the dandelions at Perry Farm, so we just look at a small area and say, well, there are this many in this area, so let's extrapolate, or let's expand that to fill the entire ecosystem. Let's assume that there's a uniform density. We have the same density throughout the park, and that's how we use sampling. Okay, so if we were to ask, well, maybe not dandelions here, but how many milkweed plants are at Perry Farm, we could do the following. So one way would be to use a quadrat, and this is a new term here, but a quadrat is a square. You could make one out of PVC or bamboo or whatever. This is a square used to mark out the sampling area, and it's really important to put this in random spots. Okay, we don't want to like find a big patch of dandelions and put it right there. That's a little too intentional, and that's going to be inaccurate. But random placement is actually sometimes kind of difficult to do sometimes. A transect is essentially the region of the ecosystem within which sampling is conducted. In this example, this area here is the transect. Okay, the teal pentagon here is the entire sampling, or is this entire ecosystem. The transect is something that the researchers would mark out and say, okay, we're gonna place the quadrats down in this transect, along this transect. Okay, just some different terminology there for you. And our sampling assumption is that density in the sample area is very similar to the density in the entire area. So if we had prior knowledge that all the milkweed was here and here, then we couldn't say that this assumption holds water, right? We are assuming, this sampling assumption is that the density across, oh, gotta do this again, okay? The density across the entire area is the same kind of density that we might see in the quadrats, okay? So this is not always true, and it does help to have some prior knowledge and maybe do some preliminary or like beforehand studies of an area if you're going to study it, but this is our assumption. Okay. Oh, looks like I moved forward. Let's see. What's happening? Oh yeah, I went a lot. All right, so some prior research may be needed to confirm that you have densities, pretty much similar density throughout. That's not always true, but we are operating on that assumption. So if you find in Quadrat 1, let's say you find 5 milkweed plants, okay? And in Quadrat 2, you find 13 plants. And in Quadrat 3, you find 6 plants. We can determine an average from this, an average density. Okay? This is fairly widespread, but we can determine an average by adding those three numbers together and dividing them by the number of quadrats that we lay down. So 5 plus 13 plus 6 divided by 3 is 8. So on average, we would have 8 milkweed plants per quadrat. And each quadrat is 2 meters by 2 meters. So this would be 4 square meters. Okay, again, a density is going to be the number in a given area. That's different from, just an average number or overall, count. Okay, so a density should be per unit area. So if we exit drawing, okay, we determined that on average we had 8 milkweed plants per quadrat. So there's our average density. Now the average density, if you divide it out, you could end up with a value of 2 per square meter. And that's actually not a bad way to do it, because that might be easier to calculate out to the whole area. And what I mean is this: if you know that your total area is 4,000 square meters, and you know that there are 2 milkweed plants per square meter, all you have to do to get the number of milkweed plants in the total area is multiply 2 times that many square meters. Okay, you see that? So you could say, oh, I'm still in yellow, 2 times 4,000, and that will give you 8,000 milkweed plants. Okay, you can also, if you don't want to divide it out, you can cross multiply. There's another video on this. Feel free to watch that if you're confused about what I'm doing here. But if 8 milkweed plants in 4 square meters, if we're assuming that we have the same density in the whole entire sampling area, then this should equal x over 4,000 square meters. Okay, if that's the total area. So then you can cross multiply. So 4x, hopefully 4x equals 8 times 4,000. Okay, I'm gonna move over. Okay, so 4x equals 8 times 4,000, which is 32,000, right? So if 4x, this is very professional, is 32,000, then we divide both sides by 4, and we can determine that x is 8,000. Okay, so we would have 8,000 milkweed plants over 4,000 square meters. Okay, hopefully that made sense. Let's see, exit drawing. I think we have to do this. Hopefully that made sense. We have a bunch of other problems that you can try out on your own. Let us know if you need more help.